In part 2, we are going to discuss bridge circuits. Let's recall the difference between DC and AC waveforms. Recall, a DC waveform was constant, but an AC waveform varied sinusoidally according to a particular frequency. Now the key difference here is that the DC waveform has an average positive value, whereas the AC waveform has an average value of 0. And the key is that the AC waveform swings below 0 even though the DC waveform must be positive. So the question becomes, how do we turn a positive current, a current in one direction, into a current that reverses its direction every 8 milliseconds? So somewhat paradoxically, we are going to start with the other problem, the opposite problem. We are going to start with AC to DC conversion. And the reason for that is because the basic circuit topology, or structure, needed in AC to DC conversion is also needed in DC to AC conversion. Let's look at a bridge circuit. We start out with two parallel circuit branches. Now inside these blocks is to be determined electronic components depending on what we want our circuit to do. Now usually in a bridge circuit at the top you have a voltage supply, and at the bottom you might have a ground. But the key thing about the bridge circuit is that the load bridges or connects the two parallel circuit branches. So here's our load. We call it R sub L. In this case we're modeling it as a resistor, even though it could be something more sophisticated like a motor. But again, the key point is that we have these two parallel circuit branches connected or bridged by the load. Let's look at a specific case of a bridge circuit called a bridge rectifier. And this is going to show you how a basic bridge can let us manipulate currents. We'll put our load here in, again, bridging the two parallel circuit branches. And we're going to look at the case where we'd like to be able to use our bridge rectifier to get current to go through this load two different directions. And in order to do that, what we're going to do is just manipulate these four switches. So let's look at the case where this switch here is closed, this switch here is closed, and these two are open. In this case, the current will flow through this closed switch through the load from left to right to ground. Now let's look at the other case. We'll go back here and we will now close this switch and this switch, but leave these two switches open. In this case, the current will flow through this closed switch through the load from right to left through this switch to ground. So in this case we have the current flowing from right to left. So we have a situation now where we can do the basic idea of what we need in either DC to AC or AC to DC conversion. That is, change a direct current supplied here between the supply and ground and turn it into an alternating concurrent current as shown by these arrows. Now that we've looked at a basic bridge, let's step back and place the bridge in the context of our DC-AC inverter system. Here we show our inverter system block diagram, which you've seen before. The bridge, in this case, an H bridge, is the third component of our system. 1, 2, 3. In this module, our goal is to develop the ideas that underlie the operation of our H bridge. So to conclude this part, this is part 2, and in part 3 of the videos for this module, we will develop the ideas that underlie the operation of the H bridge. And it will be called building a halfway rectifier with a diode.